Welcome to Section 1, Key Concepts of Monitoring and Event Management. In the exam, there will be 5 questions from this topic of the total 20. All these 5 would be understanding type of questions, meaning Bloom's Level 2 type of questions. The exam syllabus for this topic would be to get into some key concepts, such as the meanings of event, monitoring, types of monitoring, metric, threshold, alert, and the different types of events such as informational, warning, exception, even instructional is another one. And we will begin with the purpose of the practice, and then we will conclude this section with the practice success factors. There are a few, and then the key metrics of each of those practice success factors. Let's begin with the purpose of the practice. From an exam perspective, you need to know the theory quite well for the entire course or from the entire courseware, because the exam is a mix of understanding questions and application questions. Therefore, knowing some of the keywords from this courseware will be very useful, and I'll be highlighting them, of course, from time to time. So we begin with the purpose of the practice as follows. The purpose of the monitoring and event management practice is to support the normal operation of service components by observing, analyzing, and appropriately responding to changes of state in those components. There are some keywords here, such as or phrases such as supporting the normal operation, and also observe, analyze, respond to changes of state, not to every state, but to changes of state of those components or the configuration items. But we need to understand what is this normal operation. It can be subjective, it can be objective for the service components. And when we go to the objective normal operation definition, it can be the actual level of service defined in the service level agreements, or it can be in some formalized instructions or manuals, which will describe how to maintain effective operation of the service component. For example, an application functioning to be maintained properly, or a hardware to be running well. And it can also be service quality specifications such as company policies that are being followed or not. Is regulatory compliance is on or not, meaning it's going on properly or not. And there can be some lessons learned as well and documented by the service components managers so that they know what normal service operation is. Sometimes it can be subjective on the provider side. For example, a specialist might think or observe that there is unusual network traffic, and that can become a little subjective, but they can go into that and suspect something and start working on it and considering that as an event and decide what to do. Or sometimes on the consumer side, or it can also be objective, like a user might indicate that the performance of their application is slower than expected, which should be actually high because they have a high speed network. And or the user says generally that their application is slow. And some examples of the monitoring and event management could be that the monitoring can be done for any infrastructure, such as network, server, data center. It can be done for any service as well, HR or financial applications. Even information security can be monitored and managed for those events, such as the incoming network traffic. Even illegal use of software licenses could be detected, and even someone is inserting a USB drive which is not allowed, that can also be detected, and appropriate action can be taken. So that's the whole basis or meaning of what this practice works on. So there are lots of terms coming up. The first one is event. It's a change of state that has significance for the management of a service or other configuration item. It's possible that you already have some experience in this practice. Then in that case, you will recognize easily that it's about the network operations center or operational control centers or command centers. That's what they're usually known as. That's where this practice is highly worked on. So if you notice carefully, event, a change of state. Uh, States are changing all the time in infrastructure. It could be millions in a given day, or even billions on a given day. And as networks are functioning, servers are functioning, applications are functioning, particularly in large infrastructure setup, changes of state are happening always. But we are more interested in those changes of state that have significance. For example, a change of state that is informing that something is still okay or something is not okay now. So, for example, a sudden surge in memory usage or drop in CPU performance or a fluctuation in network traffic or something coming on the network which is not looking okay, a bit suspicious, and so on. So, those could be identified as a change of state that have significance. Therefore, this practice focuses on identifying those events based on their significance, first of all. And once it is identified, or they are identified, they are categorized into a specific type. So, such as informational, instructional, and exceptional, those ones. And they are prioritized so that the action can be taken based on the priority. And it is for all infrastructure, applications, services, business processes, information security, and so on. And as you might recollect from the definition or the purpose of this practice, even the timely responses need to be set up in advance so that those actions can be performed when those events do occur. And this way, the performance of the services will be kept optimal so that those services of the provider will meet their utility and warranty objectives committed to the customer. And response actions, generally defining response action will require the involvement of the technical specialist who will know, or service owners or other service personnel who will know exactly what response need to be undertaken when a specific event occurs. And these can be pre-documented in the response actions for those alerts or events. And in some cases, the response action may be thought about once the technical specialist receives an information that a specific event has occurred. And the responses could be that somebody would have to look into what fault has occurred or take an action so that incidents could be prevented or do something to just do a health check and make sure that things will continue to run properly. So we need to acknowledge that there are two different terms here, monitoring and event. So monitoring happened first, and based on that, the event management happens afterwards. And what is monitoring? It's about detecting conditions of significance. So monitoring focuses on detecting the events. So the infrastructure is continuously being monitored, and then he'll come to know what of these are events, and then they'll be tracked and recorded. So it's possible that a whole lot of data gets recorded, and it can fill up those storage boxes. And there should be policies around how long such data should be recorded or later on could be discarded. So a key thing here is the volume of data, which can be a challenge to deal with. So the recording happens, or the monitoring happens, and then the recording for the state of services, CIs, configuration items or components, that is, and give that information to the relevant personnel who will then take action, for example, analyzing it and then taking action or directly taking some action. So event management, on the other hand, focuses on determining the significance of events and then to identify what response should be undertaken. And these events information is also recorded, stored, and provided to the relevant parties. So, and so first it's a detection. So monitoring is mainly the detection. And then afterwards, once they're detected, then it's about initiating the correct response to them. Therefore, service design plays a key role here because that should lead to understanding of what should be monitored, what changes of state should be monitored. For example, changes in state to the amount of memory being consumed on a server or storage space being consumed or certain application functionalities being used or number of users logged in or network bandwidth utilization and or information security parameters and a whole other things. And how significant a change of state is. For example, something jumping up, jumping down, or even remaining steady, all that. And there need to be certain instruments to track the changes of state. By instruments, we mean sensors. If event sensor, it could be physical instruments such as a door opening sensor. It could be a software-based agent instrument, which is like collecting data from devices and it forwards to the monitoring engine or a monitoring database. So those are known as instruments, because without that, the events will not be detected, and therefore changes of state will not be known. And then during service design, the correct responses to events should also be figured out in collaboration with the concerned stakeholders, service owners, and other technical specialists. Because when the service gets released and accepted afterwards as part of the operations of the service, these parameters will have to be understood and monitored, and the events to be managed by the operational staff. Of course, they will be guided by the information systems rather than doing everything manually, because things would have been set up based on the design. So we are just still in the introductory part. There's a lot more coming up. We just touched a little bit, and we would like to go through the benefits this practice provides to the service provider and the service consumer. So for the service provider, yes, so naturally there are a few good things happening for them. They get early warnings of IT service interruption or degradation, even better service availability, IT service availability, early detection of incidents and problems. Incidents are changes of state that have caused some impact or degradation of service quality. Problems are the causes of incidents that have occurred or likely to occur. So these could be detected proactively, reactively, both incidents and problems. And better understanding of overall service health. Service health is more like an overall understanding of a service. It's just like in a health of an individual, we have a health of a service, which can depend on several parameters. We look at this service health concept a bit more afterwards. Then better availability and performance reporting based on the detection of events and the categorization and processing of them, and reduced cost of outages and reduction in firefighting approaches to incidents. Now, if the business has very less infrastructure, IT infrastructure, then a lot of things could be done manually. For example, personnel running some commands and manually detecting events and then taking action after categorizing them. But in a large infrastructure setup, we definitely need systems to detect them and systems to even process those events, and sometimes even automatically respond to those events. And some would be manual responses to those events. For the service consumer, better IT and business service availability. Note that on the consumer side, the focus is on the business, not on IT. So look out for those words in the exam questions if there are any coming up. IT versus business. Here we see both IT and business. Then reliable and predictable service performance for the consumer or the business. And on the provider side, we had a similar statement. That was we had early warnings of IT service interruption or degradation. We had better IT service availability that way. But here it's more IT and business service availability and reliable and predictable service performance. And early warnings of IT service interruption or degradation and reduced impact. So this is a bit similar. Some of the benefits could be quite common because this one was also a benefit for the service provider. However, we see the reduced impact also mentioned here, but then we had that as a separate benefit under the provider. So we have coming up events and their significance. And while there are continuous changes of state, there are certain changes of state that are significant. And those are actually defined as events. For example, storage achieving or reaching 90% of its capacity or even 70% of its capacity. It depends, on what is significant. Is 70 significant or 90 or 95 or just 100%, which might be too late. So the significance of events need to be assessed before deciding which need to be formally detected, monitored, and managed. This is done during service design and also some during service use. So meaning during service design as an example, I take the same, let's say I take an application example. It's possible that the application needs to have certain performance level, and but if that is not being achieved, then it becomes an event. Or there could be a limit or a threshold set that it is still okay, but if it's coming to like 80% of its performance, then it's okay, but need to take some action before it degrades to 60 or 50%. Because at 50, it could be like quite worse for the users. So therefore, this is how the service design will have to consider in consultation with the various personnel like business and in some cases business and user and most cases the technical and the service staff and owners. Then if those tools and activities are sufficient to address those newly discovered types of event during use, then the monitoring plans and events definition should be updated. Meaning, during the operation of the services, it's possible that the new parameters surface, which were not known earlier, are not part of the service design, therefore not being monitored, or maybe the limits or thresholds set were not okay, and they could be made better. So, for example, if previously a threshold limit was set to 80% performance of the application should be achieved, that might have been okay, but during usage, it might be found that 80 is not good enough. It needs to be at 90. And that can be done as part of the service design change. And accordingly, the monitoring and event management capabilities should be upgraded. An interesting thing is, as part of the event significance, not all events indicate that something bad or unusual is happening. And it happens with people also. Sometimes individuals might tend to measure their pulse rate or something else, blood pressure or sugar levels, just to make sure it's all okay. So it's the same here uh, with the infrastructure, that a critical server might have to be probed to check if it's still healthy or it's degraded. And if the response from that server is that I'm still okay, not to worry about me, then everything is okay. So the service is still working as designed. But there are other events which will indicate that no, it's not okay now. So those normal ones and other abnormal events, I shouldn't say abnormal, but something which is unexpected changes that could be considered as abnormal should be monitored to ensure the service health. Service health could be, for example, if I'm a user trying to print something, I may expect the print to be out within 10 seconds. And that's an indicator of the service health. The practice also identifies thresholds at which changes in normal event activity indicate potential service performance or quality issues. I did mention this a little earlier with an example like limits, but you could take another example such as network traffic. If the bandwidth is like, let's say, 500 GB, and if the network is currently utilizing 450 GB, maybe it's a reason to just wake up a bit and check if everything is okay, if it's the case all the time or most of the time. And also, if the usual traffic is much less, let's say 250 or 300 GB, and there's a spike going to 450, 470 out of 500, then it indicates that something could be happening which is not normal. So based on these potential situations that could occur, certain thresholds need to be identified. If the thresholds are incorrectly decided, then it could be unnecessary alerts popping up, unnecessary events being detected. So a thorough understanding of the services and their performances are needed, and this is where we need those practitioners who have developed services and set them up, who can give the real inputs to define those thresholds and even identify what should be significant events or even events. When I say events, they themselves are significant.